ready to the countdown.
Tahniah! Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, good evening to all students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-didik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. So before we proceed, let us begin our session with recitation of your prayers according to your religion. Okay, how is everyone doing today? I hope everyone is doing fine and ready for today's lesson. I am Teacher Eileen as the moderator for today's class, and together with me is our control host, Teacher Hafsa AYU. Hi, Teacher Hafsa AYU. And our observer, Teacher Suryati. Hi, Teacher Suryati. And of course, our presenter, Teacher Rosmaya. So, Teacher Rosmaya is from SMJK Yuhua, Kajang, Kelang. So, welcome everyone. Okay, for your information, we are now live on Teacher Rosmaya's channel. So, as a sign of support to Teacher Rosmaya, for the hard work in preparing today's lesson, please subscribe her channel as well as Teacher Hafsa, Teacher Suryati, and myself. So as usual, the lesson will last approximately for 1 hour. Please follow the class until the end and please give your full cooperation in making this class a lively one. Please take note that the certificate link will be given at the end of the session. Besides this, the link to claim the credit for today's live class as well as the presenter's username will be given too. Don't forget to claim your credit. Please accumulate the credit points to redeem the attractive prizes prepared for you. However, a 4-digit code is needed to claim the credit. The code will be revealed 1 digit at a time during the live class. So please be alert and get ready with your paper and pen. I would also like to remind students to use appropriate language and profile picture if you wish to post comments in the chat box. I am pretty sure all the students here are excellent students who will uphold a positive classroom environment. Stay focused, and if you have any questions, please write on the chat box. Teacher Rosmaya will try to provide you with the answers. So without further ado, please welcome Teacher Rosmaya.
Okay. Hi everyone. I am Madam Rosmaya. Thank you, Teacher Eileen and Teacher Sue and Teacher Ayu. Okay. So our let me introduce my name. I am. So I am Madam Rosmaya. Okay. My full name is Rosmaya binti Mohtar. And I'm a teacher, Form 6 teacher at SMJK Yuhua, Kajang, Selangor. Okay, teaching experience is 28 years old. 28 years, sorry. And this is our playlist, okay, for the physics collaboration, okay, from all teachers in the AYU team, okay, Academy YouTuber team for physics. And you can get a lot of videos from here, okay, in the link given here. Okay, then besides that, we also have the other subjects in our team. Okay, we have biology team, we have chemistry team, maths team. So one of the teacher is here with us, Cikgu Aileen, teacher Aileen. And also we have perakaunan and ekonomi team. Okay, for the maths team, okay, the teacher who leads is teacher Im, okay. And biology lead by Cikgu Faiza. And chemistry team lead by Cikgu Shahnon. And perakaunan dan ekonomi lead by Cikgu Madam Fizi, Madam Fizi. Okay, so we continue, okay, with our discussion today. So our discussion today is on this topic, okay, magnetic fields due to current. Okay? So what are we going to discuss for today? Okay, so our objective is you all, okay, should be able to state Ampere's law, okay, and then you also will be able at the end of the lesson, you'll be able to derive the magnetic field of a straight wire. Okay, if we still have time, maybe we can discuss on circular coil and solenoid, but I think we don't have time to finish all. So this will be our part 1 discussion. Okay, so next week we continue with the part 2. Okay, so magnetic fields due to current. So we are going to discuss for straight wire, okay, circular loop and long solenoid. Okay, so current that pass through straight wire and current that flow through circular loop and current flow through long solenoid, okay, will produce magnetic fields around them. Okay, so the formula of magnetic field for straight wire, we are going to derive this formula. B equals to mu naught I per 2 pi d. So I is the current flow through the straight wire and D is the distance from the straight wire, a point somewhere around the straight wire, and the magnetic field is given by this formula. Okay. Then for the circular loop, okay, the B we are going to derive, okay, is mu naught Ni per 2R. So R is the radius of the loop, the circular loop. N is the number of loop. Okay, I is the current flow through the loop. And lastly, the magnetic field due to the long solenoid given by B equals to mu naught Ni. N is number of turns per length of the solenoid here. I is the current passed through the solenoid. So we start with the straight wire first. Okay. Okay, so we are going to prove this formula of the magnetic field. Okay, so we start. Remember in the previous lesson, okay, we have discussed the magnetic field. If you magnetic field around the straight wire, okay, can be represented by the circle here. Okay. So the circle closer together means that the magnetic field is stronger near the wire here, and as it goes further from the straight wire, what happened? Okay, the magnetic field become weaker. Okay, shown by the distance between the two circle here, as you can see here. So at the near the straight wire here is crowded, right? So this means that's to show that the strength of the magnetic field is stronger here. Okay, so we will going to use Ampere's law. So what is Ampere's law? Okay, what is Ampere's law? So Ampere's law states that for any closed path, the sum of the length elements, delta L, times the B parallel, the magnetic field parallel to the length elements equals to mu naught I. So the B parallel times the element length. Where I is the current enclosed by the closed path. So in mathematical form, we can write like this. The sum of the B parallel to the element L equals to mu naught I. Okay, this described in the mathematical form, describe the statement here for Ampere's law. Okay. And mu naught is, the value is 4 pi times 10 to the power of negative 7 Henry per meter. If you use your calculator, okay, the calculator will show the value 1.26 times 10 to the power of negative 6 Henry per meter. They means 4 times pi times this one. So you got 1.26 times 10 to the power of negative 6 Henry per meter. So in the booklet given to you, usually it's written like this, 4 pi times 10 to the power of negative 7 Henry per meter. So mu naught. Okay, mu naught, what is mu naught? Mu naught is the permeability of free space. Okay. So we are going to use grip rule. Okay, right hand, make sure you use right hand grip rule. Okay, if the current is upward like this, okay, you grip the wire here. So the thumb shows direction of current and the other fingers shows the direction of B. Then at a point, okay, any point you choose on the circle here, which represent the magnetic field. Okay, how to draw the B? You draw tangent to the point there. Okay, so B, how to draw B? Tangent to the point. The line here, tangent to the point. So let's say here in the diagram, choose one point, then tangent to this circle is direction of B at that point. Refer to the direction of current, the magnetic field here. Okay. Okay. So from top view, if you look from the above here, okay, what you see, the current is coming out to you, okay, towards you. So you can represent it dotted. Dotted here, the dot here to represent the current coming out of the screen. Okay, then the magnetic field line you will see as a circle like this. So choose any point, let's say 4 points here. So at each point you draw the B. You see that the B drawn tangent to the point. Okay, tangent to the point. So we can say that the B here form the B here parallel to the length, element length is equals to the length of the circumference of of the circle. Okay, the length here is circumference of the circle. So B parallel to the circumference of this circle. So using Ampere's law, okay, so the B times the circumference of the circle formula is given by 2 pi r. Okay, 2 pi r. So this is B where it is parallel to the B parallel to the circumference of the circle. So use Ampere's law, equate it to mu naught I. Then we bring 2 pi r to the other side. So becomes mu naught per 2 pi r. So we have proven the formula, okay, for the B of a straight wire. So B equals to mu naught I per 2 pi r. So memorize this formula, okay, for the straight wire.
Okay, teacher Rosmaya,
Yeah.
you may review the first digit code.
Okay, so the first digit code, okay, for you all to claim credit is number 9. Number 9. Okay. Don't forget to jot it down and wait another 3 digits. Altogether there are 4 digits. So wait for the other 3 digits. Okay, so we continue our lesson. Our discussion today. So we've derived the formula for the magnetic fields due to the straight wire. Current flow to the straight wire. Okay, so besides using some books, if you refer to some books, they use the integration form. Just now we use this form. You can also write in using integration form. It's okay. But usually we use the normal form like just now, B parallel to the delta L. So if you want to write in the integration form also can. Okay. Okay, so before this, in the previous lesson, you have discussed the permittivity of free space. So what is the difference between permeability of free space in today's, you've just met mu naught with the permittivity of free space. So permeability of free space, we just now, okay, this is property related to magnetic field. We use mu naught. But for the permittivity of free space, this one is related to electric field. So we use epsilon naught for permittivity of free space, and we use mu naught for permeability of free space. Okay, so don't mix up these two to the meaning. One is permittivity, the other one is permeability. So permeability of free space is the property which measures the easiness offered to pass the magnetic flux when an external magnetic field is applied. Whereas the permittivity of free space, okay, epsilon naught, it is the property which measures the opposition offered against the formation of electric field. Okay. So the principle involved in the permeability of free space is magnetization, whereas in the permittivity of free space involve polarization of the electric charges. Okay, so this is the difference between permeability of free space and permittivity of free space. Okay, this value we found in the experiment lah when doing theoretically, and then during the experiment we can get this value. Okay, their relationship also from the Maxwell equation, we will discuss this in detail in the next SEM, where the speed of light is given by square root of 1 per epsilon naught mu naught. Okay, so we will discuss this in the next semester, okay, semester 2. So this is the relationship shows with the speed of light between speed of light and epsilon naught mu naught. So C is equals to square root of 1 per epsilon naught mu naught. So if you substitute both value here, okay, so epsilon naught is 4 pi times 10 to the power of negative 7, and then the mu naught, this one is mu naught, so epsilon naught is 8.8542 times 10 to the power of negative 12 farad per meter. So if you substitute into the equation, square root, so we get equals to the speed light, 2.998 times 10 to the power 8 meter per second. So if you check the formula, okay, the works for the units here, you will find that the dimension of this one is equivalent to the meter per second speed of the light. 2.998 times 10 to the power of 8 meter per second. Okay, so we discuss this in next semester. For this semester, we concentrate on this one, on the magnetic fields due to currents. Okay, so let's try a few questions on magnetic fields due to current by the straight wire. Okay, so memorize the formula already. Okay, so what is the formula just now? B equals to mu naught I per 2 pi D. So memorize that formula. So I want to test you all with this first question. So from if we plot the graph B against R, okay, so which graph correctly gives the magnitude of the magnetic field outside an infinitely long straight current carrying wire as a function of the distance R from the wire? So which one can represent from the formula just now we derived? A, B, C, D, E. We have 5 graphs. So anyone can write there in the chat box. In the chat box there. Okay, I read for you. This is very simple. Relate with the formula, with the graph here. So B against R. So can you predict the shape of the graph?
Okay, Madam dah ada yang jawab. Kau main Chai, answer D.
Okay, very good. Okay, so the answer is D. Correct. Number 4. Number 4 is D. Okay, so from the formula, okay. Okay, Chia Hao Seng also. Okay, very good. Congratulations. Okay, from the formula, you see, I is the constant, right? It's flow through the wire, straight wire. So mu naught also constant, pi also constant, 2 is a constant value. So the changes is between B and D. So the given here distance is R. So that means B is inversely proportional to R. So you've learned in secondary school, okay, this is in the form of inversely proportional. B is inversely proportional to R. So the shape should be the hyperbolic shape. Okay, so answer is D. Okay, next. Okay, so in the integration form, okay, you can write like this in Ampere's law using integration form. So the integration must be over in which one? A, B, C, D, E. Okay, who can answer this? Surface A, B, closed surface, C, path, D, closed path, E, closed path that surrounds all the current producing B. So which one is the correct one? You can write there in the chat box. So what do you think the answer? Okay, anyone? So what is meant by the integration form there? So B parallel to the element of length. So element of length, which one? Is it surface or path? Which one is the most suitable? Okay, so Chia Gao Min Chai D, Chia Hao Seng E. So the correct one is Xin Yue E. Okay, so the correct one is E. It's a closed path that surrounds all the current producing B. So B parallel to the element length. Okay, so it's a because it's equals to mu naught I, right? So closed path that surrounds all the current must include. So B just now, like just now, is a circle, and the length also is the circumference of the circle. So the best answer is E. Okay, very good. Congratulations. Okay, so we go to the next. Okay, so now it's time to use the formula. Okay, memorize the formula. So we go to the this example, okay, which relate to our daily life. Lightning bolt. Okay, a lightning bolt may carry a current of 1.00 times 10 to the power of 4 ampere for a short period of time. So what is the resulting magnetic field 100 meter from the bolt? Okay, so suppose that the bolt extends far above and below the point of observation. So you can assume that it's a straight line. So can try to use the formula just now to calculate the magnetic field. Okay, what's your answer? Okay, do all the question given here all actually posted already in the description. So you can download from there actually. You can get from the in the drive I put. Okay, so while waiting for you all to answer this, so those who cannot want to get the question, all these questions we discuss here can get from there, the description below. Okay, so any answer from you all? Okay, so Gao Min Chai, we have 2.0 times 10 to the power negative 3 Tesla. So the unit, very good. You write together with the unit. So don't forget, answer together with the unit. Okay, so let's check your answer. What about the rest of you? Do you have same answer? If you have the same answer, you can just write there in the chat box. You get same answer also can. If you get different answer, maybe there is something somewhere wrong. So let's check now. So I is given and then distance is given. Okay, so we are going to find the magnetic field. So you substitute the distance here, 100 and I current into the equation here. So you get 2 times 10 to the power of negative 5. So the power, so 10 to the power of negative 5 Tesla. So I'm the wrong one or you the wrong one? Gao Min Chai. So check. Make sure you convert all the unit to the SI unit. So we have here 100 meter, okay, already in SI unit. And this one also in ampere, okay, already SI unit. Okay, so I think this one is the correct. So be careful with the power especially. I think careless mistake done when you push the button, the calculator's button. Be careful. So this is common mistake student makes. You see, you lost 1 mark because of the careless in pushing the button for calculator. Okay. Okay, next we go to the next question. Okay, so sometimes the question not necessary wants B. So let's try this question. The magnitude of the magnetic field 50 centimeter from a long thin straight wire is 8.0 microtesla. So what is the current through the long wire? Current. Okay, this time the question is one current. Okay, so what's the current? Okay, the easier first question like this just to test your so that you become familiar with the formula. This is this simple question, direct question actually using the formula. And then to avoid you doing careless mistake when you use your calculator. So what is the answer? You can write there in the chat box. Okay, this time it wants current. Wants current. Okay, the formula, can you all remember or not? Okay, B equals to mu naught I per 2 pi D. Some books use R, but it's the same as long as you know what is the R and D represent from. So it's represent for distance, D or R can be used. So we have one answer already from Kao Min Chai, okay, 20.0 ampere. Okay, let's check. Okay, Chia Hao Seng also 20 ampere. Okay, so very good. Okay, so give you a clap. Okay. So we are going to find I from B equals to mu naught I per 2 pi D. Okay, substitute the value of B. Okay, micro Tesla. So convert to SI unit. Okay, micro here times 10 to the power of negative 6. Then mu naught 4 pi times 10 to the power of negative 7. I is what we're going to determine. And 2 pi distance 50 centimeter convert to meter. So we get I 20 ampere. Very good. Okay, so next, so we come to the sometimes diagram is given. Refer to the diagram here. So what does this mean? The diagram means the figure shows a wire carrying a current of 6 ampere entering into the page. So the cross here means the current is entering the page, is from the straight wire, and it is drawn in 2 dimension diagram. So calculate the magnetic flux density at the points P and point Q at equidistance of 30 centimeter from the wire. Okay, this is another way they might ask you in the question. Then remember that day we also discussed magnetic flux density means magnetic field strength. Okay, sometimes it is it is written as magnetic flux density. So both same meaning B. You use symbol same symbol B. So can try. What is the answer? And this time your answer must be with the direction because diagram is given. Remember that B is the vector quantity. It's a vector quantity. Magnetic flux density, B is the vector quantity. So this kind.
Teacher Rosmaya, let the student figure out. Let's take a break.
Okay. Okay, iklan.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
I think we review the second code first before we continue.
Okay, so the second code, let me check first. Okay, so the second code is number 1. Number 1. Okay, so remember to jot it down. We have 2 digits already, so another 2 digits to go. Okay, so we continue with today on question 3. Okay, what is your answer? Okay, so we have here, Okay, Gao Min Chai is 4.0 times 10 to the negative 6. Downwards. Chia Sing also same answer. Unit, okay. Tesla, okay. Don't forget the unit and direction also. Sinuet, direction. So what is the direction? But at which there are 2 positions. The question asks P and Q. So for P, which one? And for Q, which direction? Okay, so now you know the correct way. Tips to answer this question must be together with the direction. Okay, so let's check. Okay, so first you use to determine the direction. Okay, so you need to use grip rule. Okay, use grip rule. So the position of the hand is like this, where the thumb shows the direction of the current into the screen. Okay, into the screen, and the rest of the finger here shows the direction of the magnetic field or magnetic flux density. So it's a clockwise direction. So when you draw to the diagram here, sometimes the question might ask you to draw. So you must know how to draw. So you draw the circle. Make sure the circle touch the P point here, the P point, and also the Q point, because they are 30 centimeter both. So it must the circle must touch both of them lah, P and Q. Okay, so now to draw the direction, it must be tangent, okay, to this direction. Okay, especially essay question lah, they will ask to draw like this. So that's why we must discuss here also how to draw. So tangent to this point P is upward. So the B is upward. So later when you calculate, you must put this write this along together with the answer, upward direction of B. So now we calculate using the formula. So by the time now, I think all of you have memorized already this formula. B equals to mu naught I per 2 pi D. Okay, so we substitute the mu naught into the equation. I is 6 ampere, and then 2 pi, and distance 30 centimeter. Don't forget to convert to meter. So becomes 30 times 10 to the negative 2. And we get 4 times 10 to the negative 6 Tesla. Okay, that's mean correct. So your answer, all your answer is correct. And don't forget to put the direction also upward at point P. So at point Q, tangent to this point, and refer to the clockwise direction of the circle there by refer to the your right hand grip rule. So that's mean direction of B at point Q is downward. If you are asked to draw, so draw like this, tangent to this point. And when calculate the answer, okay, final answer, you get 4 times 10 to the power of negative 6 Tesla. And don't forget to write together the direction downward. Then you will get full mark. Full mark. Okay, they are opposite of each other. At same distance, but opposite of the other. Yes, Jia housing. Okay. Okay, now we try next question. Okay, so this time the questions want to find what? So let's read first. A long straight wire carries a current of 7.2 ampere. How far from this wire is the magnetic field is produced? It produced equal to the Earth magnetic field. So which is approximately about 5.0 times 10 to the power of negative 5 Tesla. Okay. Okay, so we are going to determine distance. How far? Okay. So try now. You can. I believe you all can try this very fast now, because you are familiar with the formula already. So that's why practice make perfect, right? So as we discuss here together, so you can do now. What's the answer? You can write there in the chat box. Okay, anyone? we want distance. How far means distance from the straight wire. Okay, Gao Ming Chai, your answer 28.8 times 10 to the power of negative 3 meter. Okay, the unit, meter. So be careful with the how that significant figures to be written in how significant figures. Okay, that's one tips for you to in the exam. So refer to the information given, how many significant figures given. So housing also 0.0288 meter and Sinway also 0.0288 meter. Okay, let's check now your answer. Okay, correct. So your answer is in 3 significant figures. So my answer is in 2 significant figures. It's also correct actually to write 3 significant figures, but the best one is 2. Okay, you are allowed to answer added one. Here given 2 significant figures, so you are still allowed. If you write 1 significant figures extra, it is still allowed. Okay, so using the formula B equals to mu naught I per 2 pi d. Okay, substitute the B value. So this is the Earth's magnetic field. 5 times 10 to the power of negative 5, then mu naught 4 pi times 10 to the power of negative 7. Current is 7.2 ampere, 2 pi and distance. So you cross multiply here. So you get 0.029. Okay, so good. Okay, so now next, we go to the harder question now. 2 wires now. Okay, and we are going to determine the resultant net magnetic field. Okay, magnetic flux density. Let's read the question first. 2 long straight parallel wires X and Y, X and Y are separated by a distance 10 millimeter. So the wires carry currents 15 ampere in opposite directions. So opposite direction, okay, look at the current here, opposite direction, but same magnitude, 15 ampere. So find the magnitude and direction of the magnetic flux density at given here 2 position. You are going to determine at a point midway between the wires, and then another one is at point 10 millimeter from the wires X and Y. So that's mean we are going to find the resultant magnetic field, or some books say net magnetic field. Okay, so we do question A first. Where is the point midway between the wire? Okay, so in the middle here. In the middle here. Okay, so let's say for easier to draw, okay, so we draw 2 dimension. This is the 3 dimension diagram. So we convert to 2 dimension diagram. So let's say we look through here, okay, side view. So what you can see is one wire with the direction of current out of the screen. Okay, this wire, and another wire is the current directed into the screen. Okay, you can draw like this. Then you can see clearly where how the resultant of magnetic field be. Okay, now one by one you check that. Let's say this is wire X, this is wire Y. So we use Fleming's left hand rule to determine the magnetic field at the point midway here. Okay, so that's mean here at the center here. So you use Fleming's, not Fleming's lah. Okay, I also make mistake. Actually, we use right grip hand, right grip. Okay, right hand. Okay, right hand grip rule. Okay. So you grip the wire here, and you can see follow that. Make sure that the thumb shows out of the screen. Okay. So therefore, the direction of the magnetic field is in a anti-clockwise direction or counterclockwise direction. So make sure you draw the circle. It touch the point midway here. Why? Because we are going to choose this point here to draw the B. To draw the B. So you draw the B direction is upward, tangent to this point. Upward because direction of the circle is anti-clockwise. Okay. Okay. Some of you have got the answer already. Let's check later. Okay, so we do the same for current for wire Y. So we name this BX because it comes from the B is produced by the wire X. So for BY, use the grip rule. Okay, point of your thumb is this way or into the screen. So therefore, it's a clockwise direction, the magnetic field. And when you draw, make sure the coil, what you call this, the circle, okay, touch this point, touch this point, because this is the point where we are going to determine the net magnetic field or resultant magnetic field. This is the way to draw, okay. Remember, like essay questions, sometimes they ask you to draw, so you must know how to draw, so you must practice this also. So therefore, tangent to this point shown by the blue arrow here overlap with the BX. So BY and BX overlap. BY also in the same direction as BX, which is upward. So what is the resultant? The resultant is the total of this BX and BY. So the resultant B is equals to BX plus BY upward direction. Okay. So Jia House saying you get 1.20 times 10 to the power of negative 3 Tesla upward. Okay, upward, correct. So now let's check the answer. Okay. So you, if there are many, you draw the magnetic, what you call this, the magnetic field shown by the lines here. You can see how in the center here, the resultant of B, okay, they overlap each other like this. So both, the direction is upward. Okay, that's why B equals to BX but plus BY. But specifically is at the middle here, the middle between the X and Y, point midway between the wires. Okay, so now calculation. BX plus BY. So the formula is, general formula is mu naught I per 2 pi D. Okay, so that's mean distance in the middle means 5 cm left, 5 cm right from the each wire. So D is the same. So you can just write 2 times mu naught I per 2 pi D. So you substitute the mu naught. Okay, I current 15 ampere, 2 pi, and D is 5.0 times 10 to the power of negative 3. Okay, so that's mean correct, your answer. And don't forget to write upward. Okay, Chiao Seng, complete with the direction. Very good. Okay, so now next, B. What about B? Anyone who come up with the answer can write there already. So we discuss point B. Question B, sorry. Question B, a point 10 millimeter from the wires X and Y. So you use how to draw. Usually, if essay question, they ask you to draw. So let's discuss how to draw also together with this question. Okay, this is 2 wires. We use 2-dimension diagram, easier. Okay, one current is out of the screen, the other one is into the screen. Okay, this is X, this is Y. Okay, so to draw you draw a equilateral triangle. Okay, and then the tangent to this to draw the equilateral triangle because it's 10 millimeter from wire X and wire Y. Remember, you've learned in Form 1, Form 2, Form 3, I think Form 3, secondary school. You know how to learn the topic locus, right? In maths, locus. Okay, that's what is we are going to use there, to use here. Okay, so you draw the circle here to show direction of the magnetic field. Okay, so the circle must touch the wire Y. Okay, this B red is magnetic field by wire X. So you draw the circle, touch the wire Y. Why? Because 10 millimeter, the question asks 0.10 millimeter. So you draw 10 millimeter here. And given that wire X and Y is 10 millimeter distance here, 10 millimeter with each other. So that's why you need to draw the B, touch the wire Y. And then the B from wire Y, the represent by the blue circle here, touch the wire X. Okay, this is B from wire Y. Okay, so now the intersection point here will be the point where it is 10 millimeter from the wire X and wire Y. Okay. Then at this point, you draw the magnetic field B. for the blue circle to present B from wire Y and red circle B from wire X. So you draw the tangent at this point, like this. So tangent to this point this way, and tangent to circle B this way. Okay, right? BY. So what is the resultant? Resultant B. How you know the direction? So the direction you use a vector diagram. Vector diagram. So housing, right? Upward. Okay, let's check. So you draw. You can use a parallelogram method. Okay, parallelogram method or triangle method. Okay, this one same as here. And it is the B resultant pointed upward, points upward. Okay, so the B resultant points upward. And it's vertically upward. How you know it's vertically upward? Because BX and BY is the same, right? Remember the formula B. What is the formula B? B is mu naught I per 2 pi D. Distance is the same D. I also same 50 ampere. So that means BX is equals to BY. Right. So if they are equal, so the magnitude also equal. So they will form a equilateral triangle here. So that's why B points vertically upward. B points vertically upward. So BX equals to BY. So the B resultant is also same as either BX or BY. Okay, let's check whether your answer is correct or not. Housing right there. Okay, so substitute the value mu naught. I is 15, 2 pi, and distance 10 millimeter at this point. So 3.0 times 10 to the power of negative 4 Tesla. So what's your answer? Correct. Okay, so very good. 3 times 10 to the power of negative 4 Tesla. And don't forget direction.
Okay,
so
teacher Rosmaya.
Yeah?
Let's review the third code.
Okay, so it's time for the third code. So the third code, okay, I check first. It's number 5. Okay, so the third code is number 5. So jot that down for you all to claim credit. Okay, sorry, twisted tongue. So number 5 just now. Okay, so another one digit to go. So stay until the end of our discussion today. Okay, now, done question 5. So we go to the next question. Okay, so this one is for you all to try yourself. Okay, similar to the question 5, but this time is given 2 long straight wire are parallel and carry current in the same direction. Okay, but this time the current is different. One is 8 ampere and another one is 12 ampere. And the wires are separated by 0.40 centimeter. Okay, so find the magnetic field strength in Tesla. Okay, at point midway between the wires. In the middle. Okay, so try and do now. Okay, we discussed the question 5. So question 6 for you to test you. Okay, this time different B. Different current. So diagram not given, so it's up to you to draw which way. Oops. Okay, anyone can get the answer just now? I accidentally give you answer just now, but it's okay. Did you get the same answer with me? Okay, don't be afraid to write your answer there in the chat box. If you have same answer, you can write same answer. Okay, I see only a few students on here. Post your answer. Okay. So the clue is can use the diagram just now. And the grip rule, remember to use the grip rule to determine the direction of B. Okay, so housing. Okay, you get again the answer 4 times 10 to the power of negative 4 Tesla. So this is objective question, so no direction needed. Chia Housing, same answer with me. Okay, so let's check the answer. Okay, actually you can draw like this also instead of using the just now diagram. So many methods to draw the diagram. So you can draw like this, current this way, 8 ampere, 12 ampere. Okay, so Sinway also same, Gao Ming Chai got E. So check the answer. Okay, so this direction, you can draw like this, okay, current, and then use grip rule, your hand position like this. So that's mean in the middle here, the B direction is which way? Into the screen. So shown by the cross. So this time the cross here means direction of B into the screen. Into the screen, not the direction of current, the direction of B. Okay, into the screen. Okay, this is for this wire, the above wire. The top wire, you grip like this. Okay, grip like this for 12 ampere current in the wire here. So you grip like this. So in the middle here, the B direction is out of the screen. You see, dot. This is another way to draw the diagram. We discussed this because sometimes in the exam they ask you to draw. So coming out like this. So that means they are opposite with each other. Okay. They are opposite with each other. The B direction. Okay, so now you know that it's opposite direction, so that means we minus them. Minus them. Okay, so calculate B. Let's say we the B dot here, B dot here means B out. So let's say out of the screen considered positive and into the screen considered negative. That's why B out, B out minus B in. Okay, and the formula we use this one, mu naught I per 2 pi D. Okay, so you substitute the value of B out. B out is from this wire, 8 ampere current. Distance in the center, at the center is 0.4 cm. Okay, 0.4 cm is separate, the separation distance between this. So at the center means divided by 2. Okay, so you know where you go wrong already? Who get wrong answer? Okay, maybe you your mistake is by this one. Separation is 0.4 centimeter. So at the center means divide by 2 becomes 0.20. Convert to meter. Okay, this is common mistake student makes. Okay, next for the BX also the same, but the current is 12 ampere. You minus what you get? You get negative, right? So what does this mean, negative? So previous, initially, okay, we have define negative as into the screen. So that's mean this negative answer means the direction is into the screen. Okay, into the screen. Just in case the question is the essay form. So and diagram is given. So be careful. The answer is into the screen. So this is objective question, okay, multiple choice question. So it didn't mention here. So that's why no positive, no negative, no direction given here. We want only magnitude. Okay, so that's the. And any question or not? I hope you all understand. If you cannot understand, you can ask in the chat box there. Okay, so I think we can go through one more question. Last question we can discuss here. Okay, two long straight wire. Okay, here two long straight wire. Current carrying parallel wire across the x-axis. Okay, and it carries current I. Another one is 3I. Okay, same direction. Same direction. Okay, at what value of x? Here the use here is the put rule. Let's say you put ruler here along the x here. So it is marked 0, 1, 2, 3, 4, 5, 6, 7 centimeter. So at what value of x is the net magnetic field 0? Okay, this time the resultant magnetic field is given. We want it to be 0. So at which position? Is it here or in the middle or on the other side? Okay, So this time, our questions come harder and harder this time. So what is the value of X? Which one? Is it at 0, 1 or 3, 4, 5? Or anywhere here? Or 7 here? Here, given here. 7. For the resultant or net magnetic field to be 0. Okay, so what to do? So that's mean you equate the B. Okay, because we've done already question 6, it is understood that the B must point, one is to the left, the other one is to the right, or if one is into the screen, the other one must be out of the screen. So they must balance. So how to do it? Equate them because they must be balanced so that the net magnetic field becomes 0. So we've done question 5 and 6 already, right, to determine the B. So for the same current, here that's mean the B is opposite direction. So you equate them to get the value of distance first and relate with the ruler put here, the X value of X here given. Okay, can you get the answer? If you can get, can write there in the chat box. Okay, this question hard for you? I give the clue already, So the current, one is I, the other one is 3I in the form of I. Values not given, but it's okay because you can cancel out later the two values I. Okay, no answer there. Is it hard? So I think we discuss lah this question. Because it almost time. We have about few more minutes. So we discuss this question. So the answer is C. If you get the answer, okay. So you can draw like this. One is I, the other one is 3I. Okay, use grip rule to determine direction of B. So the B is for this wire current I into the screen, and the other one will be out. So out of screen, so dot. So they are different in direction. This one just to be sure. You can see here how if we've done already in question 6 and 5. So same direction means one different direction in B. Okay, so now these two must be equal in magnitude so that the resultant of magnetic field equals to 0. Okay, so BR resultant equals to 0. So B out equals to B in. So we substitute the value for this wire distance at the center here. Let's say D. So we substitute as D. We are going to find D. So mu naught 3I per 2 pi D. And for the other one, that's mean distance given here 4 centimeter. So 4 minus D. So at the middle somewhere here, for 4 minus D here, the remainder of the distance here. So you put 4 minus D. So D is what we are going to determine. Okay, so you cancel out mu naught, cancel out 2 pi and I. So cross multiply. So you get 12 minus 3D equals to D. Okay, then D equals to 3. Okay, but D equals to 3 measured from where? From wire 3I. So check the here, check the ruler put here, the X, scale X here, put here. So 3 measured from here. So 1, 2, 3. So you are lucky because the mark here also 3. So the answer is 3. Yeah. So if the 2 wire here is put in another position, let's say at 0.3 and 0.7, so the answer is not 3. The answer may be 4. So be careful with the question. Okay, be careful with the question. So the answer is same as this one. D, refer, measured from the 3I ruler. So 6 minus 3, so you get 3. Okay or not? I think that's all. For I think 7 questions enough for you to understand the how to use the B equals to mu naught I per 2 pi R. So next class, next week we go to part 2 discussion on this chapter. Okay. The other two we will discuss next. Okay, so we stop now. Okay, I give this to the moderator.
Okay,
Teacher
before
Aileen.
this, Teacher Rosmaya, do you want to review the final
last
code?
Okay, so the last code is number 4. Okay, number 4. So
Okay,
you already.
All right, so we thank you to Cikgu Rosmaya. So I sure students should gain a lot of info from her. So, but now we have already reached the end of today's session. So thank you so much to those who are able to follow our session from the beginning until the end. So before we end our session for today, and as a sign of support, please click the subscribe button below and activate the bell icon so that you will not miss the next class session. Then if you find that the lesson is beneficial, hit the like button and share to your friends in your social media. Spread and share the goodness. Now the link, is that the link? So yeah, I think the link of the certificate and the link of credit record, as well as the presenter's username, not yet, presenter's username. I can see that is the link for CJ, link for credit, presenter's username.
Okay, I
Right,
give already.
so the presenter username, okay, they are already given in the chat box. Now, please take note, the link will end 15 minutes after this live. Make sure use the e-DDate email for the certificate and the correct ID, e-DDate Junior for the credit record. Any incorrect email or ID used will not be entertained. If you don't have e-DDate email or ID e-DDate Junior, please apply. If you wish to get more information on the online classes, go to www.academyyoutuber.com. And to those who haven't joined e-DDate Junior Telegram, please do so. Before we end, I would like to thank all the students for joining today. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter too. I think that's all for now. See you in another session. Don't forget our hashtag bermula percuma, selamanya percuma. Stay safe till we meet again next week, same day, same time. So, bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma.